Hello everybody. In this section, we're going to do practice using table of Laplace transforms. Here, I have prepared some formulas. From 1 to 10, 11 to 20, 21 to 30, 31 to 40, and some extra formulas: cosine hyperbolic cosh, sine hyperbolic sinh, and different forms of gamma functions. You can pause the video and copy them and follow with me. Example 1. We're going to take Laplace of this given function. So our first step is to wrap whole function in Laplace. 8e to the negative t plus e to the 5t plus 4t squared minus 7. The plus is the linear operator, so we can separate each term and take out the coefficient. So we can rewrite this as 8 Laplace of e to the negative 3t plus Laplace of e to the 5t plus 4 Laplace of t squared minus Laplace of 7. Here we're going to take Laplace of constant, which is number 1 on the table. Laplace of constant is constant over s. This one is the Laplace of polynomial function t to the some n degree. So this is as in number 3. And Laplace of any polynomial function is n factorial over s to the n plus 1. Here our n is 2. And these two functions are e to the at kind of functions, which is in number 2. And e to the at is 1 over s minus a. In the first case, our a is negative 3, and in the second case, our a is 5. Now we can take the Laplace of each term. The first one will be 8 times 1 over s minus 3 plus 1 over s minus 5 plus 2 factorial over s to the 2 plus 1 times 4 minus 7 over s. Now we can simplify. So 8 over s plus 3 plus 1 over s minus 5 plus 4 times 2 factorial is 8 over s to the 3 minus 7 over s. So this is the answer. Let's do another example. In this example, we're going to take Laplace of cosine and sine functions. Laplace of sine is as in number 7 here, and Laplace of cosine is as in number 8 in the table. Laplace of sine is a over s squared plus a squared, and in our case, our a is 5 here. And Laplace of cosine is s over s squared plus a squared, and in our case here a is 3, so we can take Laplace of these two functions. So Laplace of 3 cosine of 3t minus 9 sine of 5t. We can separate the terms and take the coefficients out. 3 Laplace of cosine of 3t minus 9 Laplace of sine of 5t 3 times s over s squared plus 3 squared minus 9 times a over, which is our 5, over s squared plus a squared. Now we can simplify. So 3s over s squared plus 9 minus 45 over s squared plus 25. So this is the Laplace of given problem. Let's do another example. In this example, we have e to the at kind of function, as in the number 2. We have cosine function, as in number 8. And we have e to the at times cosine of bt, as in number 20. which is going to be s minus a over s minus a, the quantity squared, plus b squared. So this is going to be as in number 20. So this is going to be s minus a over s minus a, the quantity squared, plus b squared. In our case, this 2 is our a, and this 8 is our b. We already know cosine function. It's going to be s over s squared plus a squared, and our a term is 5. And e to the at function will be 1 over s minus a, and our a term is 2. Now we can take Laplace of this. So Laplace of e to the 2t plus cosine of 5t minus e to the 2t times cosine of 8t. Now we can separate. So Laplace of e to the 2t plus Laplace of cosine of 5t minus Laplace of e to the 2t times cosine of 8t. This is as in number 2. This is as in number 8. And this is as in number 20. So this is going to be 1 over s minus 2 plus s over s squared plus 5 squared minus s minus a, s minus 2 over s minus 2, the quantity squared, plus b squared. Now we can simplify this. 1 over s minus 2 plus s over s squared plus 25 minus s minus 2. If you expand this, you're going to obtain s squared minus 4s plus 4 plus 64, which is going to be s squared minus 4s plus 68. So this is the answer. Let's do another example. Here we have sine and sine hyperbolic sinh functions. Sine is as in number 7 in our table, and sinh will be as in number 17 in our table. Number 17 is a over s squared minus a squared. So we know that sine is a over s squared plus a squared. Sinh is a over s squared minus a squared. In our case, our a is here 7 and our a here is 2. So we can separate the Laplaces. 3 Laplace of sine of 7t plus 5 Laplace of sinh of 2t. Now we can apply transformation formula. So 3 times 7 over s squared plus 7 squared plus 5 times 2 over s squared minus 2 squared. Now we can simplify. 3 times 7 is 21 over s squared plus 49 plus 10 over s squared minus 4. So this is the answer. Let's do another example. Now we have t cos 5t. We don't have direct formula on the Laplace transform for t cos of some at function, but we're going to make it up using number 35. Number 35 is t to the some n degree of f of t will be equal to negative 1 of n times f to the nth degree derivative of s. Let's write. This is going to be like as in number 35, where n is equal to 1, because this is t to the 1. And the formula for number 35 is negative 1 to the n times f of nth degree derivative of s. So our f of s is equal to Laplace of t times g of t, which is going to be equal to negative g prime of s. Because if we apply this formula, negative 1 to the 1, our power here 1, f to the nth derivative, which is first derivative of s, will be negative. We need to change the name of the function, g prime of s, where g of t will be, here in our case, cos of 5t. Now our g of s is equal to, we're going to take the Laplace of cos of 5t. We know the formula for cos, which is going to be s over s squared minus a squared, as in number 18. So we can make up Laplace of cos of 5t, which is s over s squared minus 25. And we need to make up g prime of s. We're going to take the derivative of this function using the quotient rule. Let's remember the quotient rule. Quotient rule is f prime times g minus f times g prime over g squared. Here in our case, our f function is s. Derivative of s is 1. Our g function is s squared minus 25, and derivative of s squared minus 25 is 2s. And if we apply it into this formula, we obtain g prime of s as negative s squared plus 25 over s squared minus 25, the quantities. Now we can make up our f of s. F of s was equal to negative g prime of s using number 35. So if we negate g prime of s, we find f of s. So if we negate this, we obtain s squared plus 25 over s squared minus 25, the quantity squared. So this is the Laplace of t cos of 5t. We can actually formalize t cos of some at function like this. So Laplace of t cos of some at kind of function, let's say t to the nth, will be this. It's going to be negative 1 to the nth power, whatever the power here will be here, times derivative, nth degree derivative, times Laplace of f function. So here in our case, f of t is cos of at. So we can take Laplace of cos of at and multiply it by negative 1 to the nth power, whatever power is here. But we also have to take the derivative of this Laplace we have taken. So I can make here some parentheses. Let's apply this formula practically on something simple. Let's say we have t squared cos of 3t. Then we're going to have negative 1 to the second power, and we're going to have d squared over ds squared, which is the second derivative of Laplace of that cos of 3t. So we're going to start from innermost parenthesis here, which is cos of 3t. Cos of 3t is s over s squared minus 9. We're going to take derivative of this 2 times because we need to take the second derivative and multiply it by negative 1 squared, which is positive 1. So if we take the derivative 2 times, we obtain Laplace of this function. So we can formalize this as in here. Or you can go step by step using 35, break it into 2 functions, and then make up your g of t, and then find your f of s. Let's do another example. Example 6, t squared times sine of 8t. Again, this example is the same as example 5. There is no direct formula in the table, but you can utilize number 35 using n as 2 because power is here 2, or you can also use the formula we have driven in example 5, which was negative 1 to the nth power times derivative of nth degree derivative of Laplace of f of t function, where f of t is the sine of 8t in our case. So this is the formula we have driven, or you can go number 35 and use t to the n, in our case t squared times f of t is equal to negative 1 to the nth degree times f nth derivative of s. Let's use the formula we have driven because it's more practical here. So in our case we have negative 1, our n is 2 second power, so second derivative of Laplace of sine of 8t. So we obtain negative 1 squared is positive 1, so we don't need this. So second derivative of Laplace of sine of 8t will be Laplace of sine is a over s squared plus a squared, which is going to be 8 over s squared plus 64. And we're going to take the second derivative of this, so we're going to obtain negative 16 times negative 3s squared plus 64 all over s squared plus 64 to the third power. Let's do another example. Example 7, t to the 3 over 2. For this, you can utilize number 6 alone, t to the n minus 1 half, or you can utilize number 26 plus number 5 together. Our number 5 is the square root of t. This is the Laplace transform. And number 26 is the integral from 0 to t f of v dv is equal to f of s over s. Let's use number 26 plus number 5, and I leave number 6 to you. So integral from 0 to t square root of v dv will be equal to f of s over s. In our case, it's going to be 2/3 t to the 3 over 2. So if we solve for t over 3 over 2 in this equation, we obtain t to the 3 over 2 will be equal to 3 over 2 integral from 0 to t square root of v dv. Now our f of t is square root of t, and f of s then will be square root of pi over 2s to the 3 over 2 using number 5 here, Laplace transform. Now our new function g of s will be 3 over 2 times square root of pi over 2s to the 3 over 2 times 1 over s. So if you simplify this, you obtain 3 times square root of pi over 4s to the 5 over 2. So this is the answer. You can again use 26 plus 5, or you can use number 6 directly and you obtain exact same answer. Let's check another example. Number 8. 8t to the 3 over 2. For this, we're going to utilize number 24, which is f of ct, some constant times t. In our case, our constant c is 8 here. Let's see how the transform will be for number 24. So some f of ct will be 1 over c times f of s over constant. So 1 over c times f of s over constant. Here in our case, our g of t is t to the 3 over 2, this part. And our f of t will be g times 8t. Then our f of s will be equal to 1 over 8, 1 over constant c. We are applying this transformation formula. 1 over 8 times g of s over 8. Now that's going to be 1 over 8 times. We know how to do this part. It's going to be 3 times square root of pi over 4 times s over 8 to the 5 over 2. So this is the answer. Let's check the last example of this section. Example 9. T times g prime of t. Here we're going to utilize number 35 as we did in the previous examples. And extra, we're going to utilize number 29, which is the Laplace of f prime of t kind of functions. So here, our first step is to wrap the Laplace of t times g prime of t will be equal to negative d over ds Laplace of g prime. Remember the formula, negative 1 to the nth power times f nth degree derivative of s. Now we're going to rewrite as d over ds, and Laplace of g prime is number 29. Laplace of any f prime of t will be as in number 25, which is s times f of s minus little f of 0. So in our case, it's going to be s times new defined function g of s minus g of 0. So we can rewrite this as negative g of s plus s g prime of s minus 0, and that is going to be equal to negative g of s minus s g prime of s. So this is our final answer. So negative g of s minus s times g prime of s. All we did here was, starting from number 35, obtaining Laplace of t times g prime of t, and then we applied number 29 because in our case here g prime of t is our f prime of t, which is the formula of number 29. And if you carefully use the algebra, you obtain this. So thank you for watching this section of Laplace Transform. I hope you benefit this video. My recommendation is to go through all formulas in the table and do practice of each at least once, so you will be strong on this Laplace Transform table. Thank you for watching. Please subscribe my channel to support. Thank you.